Hi everyone, welcome to lesson 5 of the Advanced Higher Stats course. In this lesson, we're looking at laws of expectation and variance. You will find this skill on page 20 of the Advanced Higher Stats course spec 2023 version. And by the end of this lesson, you should be able to use the laws of expectation, laws of variance, and you should be able to convert from the standard deviation of x to the variance of x. Jump straight into it. So this is the first law of the laws of expectation, which is E of A of x plus b is equal to A times E of x plus b. Now, what this means, you'll gradually learn when we go through these questions, and it'll be clearer. So let's start off with these questions. I recommend you do them first and try and problem solve your way through them, and then you can see what I do. The first question is find the expected value of a four-sided dice. So we know the outcomes of a four-sided dice are 1, 2, 3, 4, which means the expected value is equal to the total. So 1 plus 2 plus 3 plus 4, which is 10, over the possible different outcome, which is over 4, that's 2.5. Now, the next question is find the expected value of a four-sided dice where the row is multiplied by 3. And now what this is asking is for us to find E of 3 of x, because it's the expected value of a four-sided dice, but you're multiplying it by 3. And we know that here we can take out A and take it out of the bracket. And that's what we'll do here. We'll treat 3 as an A. So E of 3 of x is actually equal to 3 times E of x. And we know from the previous question, E of x is 2.5. That 3 times 2.5, which is 7.5. Another way to do this is just by multiplying every row by 3. So instead of getting 1, 2, 3, and 4, you'll instead get 3, 6, 9, 12. You add them all together, which gives us 30. You divide by 4, and that gives us 7.5. Now the final question is find the expected value of a four-sided dice where the 8 is added to the row. So now what this is asking is asking for E of x plus 8. And now we can treat 8 as b in this formula, b here, and we can take it out of the bracket, and that will give us E of x plus 8. We know E of x is 2.5 plus 8, which gives us 11.5. Sorry, no, it gives us 10.5. And another way to do this is just by adding 8 to all the rows. So instead of getting 1, 2, 3, and 4, we can have 9, 10, 11, and 12. Overall, that would give us 42 over 4, which gives us 10.5 as well. Now, the second law of expectation is adding or subtracting two expectations. And this can only happen when x and y are independent and they have no influence over each other. So if E of x is high, that doesn't mean E of y will also be high. So let's move on to the questions. Again, I recommend you do all these questions I'm going over first before I do them. So find the expected value of an 8-sided dice. So that again is asking us to add up all the possible outcomes, 1, 2, 3, 4, 5, 6, 7, 8, and that gives us 36. Whoops. And we divide this by 8, and that gives us 4.5, which is the expected value of y, the 8-sided dice. Now, question 2 is the expected value of x of a four-sided dice is 2.5. Find E of y minus x. So let's do that now. Now we can see here, if it's E of x minus y, we can change that into E of x, well, minus y, but outside of the bracket. minus e of y, sorry. So e of x minus e of y. And here, we're just flipping the two variables here. So in the general formula, e of x is my e of y is being taken away from e of x, whereas here e of x is being taken away from e of y. So we can separate these from the back bracket, and that will give us e of y minus e of x, and that would give us 4.5 minus 2.5, that's 2. And this means, on average, the difference between a random roll on an 8-sided dice and a random roll on a 4-sided dice will be 2. But now what would happen if we add both of them together? What would be the expected value of that? Well, same thing here. We're adding e of x and plus y, and we can use the formula or the law, take it out of the singular bracket, and we will get e of x plus e of y, which is 2.5 plus 4.5, and that gives us 7. The third law of expectation is e of a of x plus by is equal to a times e of x plus b times e of y, where x and y are independent, so they don't have an inf with each other. Sounds a bit complicated, but let's run through these questions. So we know from the last two laws, e of x here is 2.5 and e of y is 4.5. Find e2x plus 3y. Let me write that down here as well. e2x plus 3y. And I like to take this into 2 steps. So first, let's take them out the same bracket. So e of 2x plus e of 3y. And then we'll take out the 2 and the 3. So 2 times e of x plus 3 times e of y. That gives us 2 times 2.5 plus 3 times 4.5, which should give us 18.5. Okay, and the next question is similar, but it's a subtraction. E of 5x minus 3y is equal to e of 5x minus the expectation of 3y, which is equal to 5 times e of x minus 3 times e of y, which is 5 times 2.5 minus 3 times 4.5, which should give us negative 1. Okay, let's move on to the laws of variance, and the first law is v of a of x plus b is equal to a squared times v of x. So here the multiplier gets squared, and if you're adding or take away anything, it just gets ignored. And try and do these questions, and I'll do them as well. So for a 4-sided dice where e of x is 2.5, find v of x. Now we can use the formula that we learned last lesson. V of x is equal to e of x squared minus e of x all squared. Now e of x squared. So at the top, let me just write the values. So normally we have 1, 2, 3, 4. Here we have 1, 4, 9, and 16. And since the chance of all of these happening is 1 over 4, we can add them all together and divide by 4 instead of timesing each of them by their chance of happening and getting the expected value that way. So if we add them all together, we will get 30. So 30 divided by 4 minus 2.5 squared, and that should give us 1.25. Okay, so find the variance for two four-sided dice, or find v of 2x. V of 2x. So we know from the formula above, 2 can be treated as a. So that means when we take it out, we square it. So that means 2 squared v of x, which is equal to 4 times 1.25, which gives us 5. So v of 2x is equal to 5. The third question, if 4 is added to the roll of a four-sided dice, find its variance, v of x plus 4. V of x plus 4. And we know from the formula above, if we have b, which is our plus 4 here, it just disappears. So that just means v of x plus 4 is equal to v of x, which is equal to 1.25. And why that is the case is originally x is 1, 2, 3, 4 with a range of 3. So 4 minus 1 is 3. Let's say we add 4 to all of its rolls. Now we have 5, 6, 7, 8. And these are the possible outcomes. But the range here is still 3. So the values may be higher, but the range is the same and the variance is the same. So if you add or take away from the roll, it won't affect the variance. Now we move on to the second law of variance, which is v of x plus or minus y, both equal to v of x plus v of y. Let's move on to these questions. For an 8-sided dice, E of y is 4.5. Find V of y. Well, here we use the formula E of x squared minus E of x all squared is equal to variance. That gives us 25.5 minus 4.5 squared. And this gives us 5.25 as the variance. If the roll of the 4-sided and 8-sided dice were added, find V of x plus y when V of x is 1.25. This is very simple. V of x plus y is equal to V of x plus V of y, which is 1.25 plus 5.25, which gives us 6.5. If the roll of the 4-sided and 8-sided dice were taken away, find V of y minus x. Well, if you look at the formula, it doesn't matter if we're doing x plus y or x minus y. When we take them out of bracket, it'll be plus. So V of y minus x is still equal to V of y plus V of x, which is 5.25 plus 1.25, which gives us 6.5. We've covered all the laws of expectation and variance, and now we have to look at the relationship between sigma and variance again. So, just like what we learned last lesson, variance is equal to sigma squared. So how do we answer these questions then? The sigma of x is 3. Find v of 3 of x. So first let's find v of x. That's equal to sigma squared. Since sigma is 3, that's 3 squared, which gives us 9. Now we have v of 3x, and we want vx on its own. So when we take out a 3, we square it. So it's 3 squared times v of x, which is 9 times 9, which is 81. So v of 3 of x is 81. Now if sigma is 5.5, find v of x plus y. So first we have to find v of y, which is equal to sigma of y, you can write here if you prefer that, squared, which is equal to 5.5 squared, which gives us 30.25. Now v of x plus y is the same as v of x plus v of y, which is 81 plus 30.25, which gives us 111.25. This exam question tests most of the things you've learned, so have a shot at this. Okay, so the question is, an unbiased regular octahedral 8-space die is thrown. Let the random variable x be the score shown on this die. Now we did this in a previous question as well. So we know e of x is 4.5 and v of x is 5.25. An unbiased cubical die is also thrown. Let the random variable y be the score shown on this die. Calculate e of 3 of x minus 2y and v of 3x minus 2y. So first let's find e of y and v of y. The expected value of y is 3.5. V of y is equal to e of y squared minus e of y all squared, which gives us 15.17 minus 3.5 squared, which gives us 35 over 2, or 2.917. Now we can go on to answer the actual question, which is e of 3x minus 2y is the same as 3 times e of x minus 2 times e of y, which is 3 times 4.5 minus 2 times 3.5, which gives us 6.5. Now the same for variance. V of 3x minus 2y is equal to 3 squared v of x minus 2 squared v of y, which gives us 9 times 5.25 minus 4 times 2.917. And this should give us 707 over 12, or 58.92. Here's a marking scheme for the question. So e of x was 4.5, v of x was 5.25, e of y was 3.5, and v of y was 2.917. And then we have 6.5 for first answer and 58.92 for the variance. That's the end of the lesson. Now you should be able to use the laws of expectation and variance. You should also be able to convert from sigma to variance and use that step along with the laws that you've learned today.